So fortunately, you don't have to do things the hard way in Spark when you're doing machine learning. It has a built-in component called MLLib that lives on top of Spark Core. And this makes it very easy to perform complex machine learning algorithms using massive data sets and distributing that processing across an entire cluster of computers. So very exciting stuff. Let's learn more about what it can do. One more thing I need to cover before we start diving into some real code, and at that point things will make a lot more sense, is MLLib, and that is a component built on top of Spark for machine learning, the machine learning library. So obviously that is very relevant to this course. So what are some of the things MLLib can do? Well, one is feature extraction. So one thing it can do at scale is term frequency and inverse document frequency stuff, and that's useful for creating, for example, search indexes. And we will actually go through an example of that in a few lectures from now. So the key again is that it can do this across a cluster using massive data sets. So, you could make your own search engine for the web with this potentially. It also offers, your basic statistics functions, chi-square tests, Pearson or Spearman correlation, and some simpler things like min, max, mean, and variance. None of those are terribly exciting in and of themselves, but what is exciting is that you could actually compute the variance or the mean or whatever, or the correlation score across a massive data set, and would actually break that data set up into various chunks, run across an entire cluster if necessary. So even if some of these operations aren't terribly sexy, what's sexy about it is the scale at which it can operate at. It can also support things like linear regression and logistic regression. So if you need to fit a function to a massive set of data and use that for predictions, you can do that too. It also supports vector machines. So we're getting into some of the more fancy algorithms here, some of the more advanced stuff, and that too can scale up to massive data sets using Spark's MLLib. There was a naive Bayes classifier built into MLLib. So remember that spam classifier that we built a few lectures ago? You could actually do that for an entire email system using Spark and scale that up as far as you want to. Decision trees, one of my favorite things in machine learning. That too is supported by Spark, and we'll actually have an example of that later in this course. K-means clustering. We'll also do an example of that later in the course, and you can do clustering using k-means, using massive data sets, using Spark and MLLib. Even principal component analysis and SVD. We can do that with Spark as well, and we'll have an example of that too. And finally, there's a built-in recommendations algorithm called alternating least squares that's built into MLLib. Personally, I've had kind of mixed results with it. It's a little bit too much of a black box for my taste, but I am kind of a recommender system snob, so take that with a grain of salt. Using MLLib is usually pretty straightforward. There are just some library functions you need to call. It does introduce a few new data types, however, that you need to know about. One is a vector. And an example of a vector, remember when we were doing movie similarities and movie recommendations? For example, a vector might be a list of all the movies that a given user rated, okay? And the difference between a sparse vector and a dense vector, so let's say we have, remember there are many, many movies in the world, and a dense vector would actually represent data for every single movie that user watched, whether or not they actually watched it. So for example, let's say I have a user who watched Toy Story. Obviously, I would store their rating for Toy Story. But if they didn't watch the movie Star Wars, I would actually store the fact that there is not a number. There is no value. There's missing data there for Star Wars. So we end up taking up space for all these missing data points with a dense vector. A sparse vector only stores the data that exists. So it doesn't waste any memory space on missing data. Okay, so it's a more compact form of representing a vector internally, but obviously that introduces some complexity while processing. So it's a good way to save memory if you know that your vectors are going to have a lot of missing data in them. There's also a labeled point data type that comes up, and that's just what it sounds like, a point that has some sort of label associated with it that conveys the meaning of this data in human readable terms. And there is a rating data type that you'll encounter if you're using recommendations with MLLib. So, that actually can take in a rating that represents a 1 to 5 or 1 to 10, whatever star rating a person might have, and use that to inform product recommendations automatically. So I think you finally have everything you need to get started here. Let's dive in and actually look at some real MLLib code and run it. And then it'll make a lot more sense. So that's MLLib. Makes it very easy to perform complicated machine learning algorithms potentially on very large data sets and distribute that processing across an entire cluster. Like I said before, Spark is still young and it's growing every day, so I expect these capabilities to keep expanding and evolving as time goes on. Cool stuff. Let's actually get our hands dirty and write some MLLib code and actually do some real machine learning using Spark up next.